Good morning to everyone. Today, in our analog electronic circuits lecture series, we are going to discuss about transistor. Come, let's get into the topic. So, what is transistor initially? So, the transistor, by the name itself, you can understand, you can explain the term. So, transistor is nothing but of transfer the resistor. That means from low resistance to high resistance. The current will be passing from low resistance to the high resistance. That is called as a transistor. So transistor will be used for two major applications. One is it will be act as a switch, which is nothing but of on and off. Sometimes the circuits need to on, and some cases circuits need to be off. So that will be done by the transistor. And another one important application of the transistor is amplifier. It will act as an amplifier. So what is amplifier? Amplifier in the sense the weak signal will be boost up to the larger signal. So that is called an amplifier. This process is called as an amplification process. So these two are the applications of the transistors. And coming to the transistor types, it has two types. One is a BJT, another one is a MOSFET. So that is MOSFET is nothing but of obviously it's called as a field FET. That's a field effect transistor. BJT is a bipolar junction transistor, and FET is a field effect transistor. And BJT, it has a three terminals. One is a BCE. B is nothing but of base, C is a collector, and E is a emitter. And again, the BJT, which can be classified into two types. One is a NPN transistor, another one is a PNP transistor. So in a previous session, we have discussed about diode. So diode, which has two materials, that is a P type and N type. It is manufactured with the two materials. In the case of transistor, transistor will be this BJT transistor will have a two PN junction diode. If you join together, that will create the BJT. So that is called a NPN or PNP transistor in the case of BJT. In case of field effect transistor, similar to the BJT, it is also having three terminals. One is a gate, another one is a source, then drain. So it has again similarly to the BJT, that's NPN and PNP. It has P channel FET and N channel FET. So what is the difference between these two? Here is nothing but of BJT is a current controlling device, and the field effect transistor is a voltage control device. So this is the major difference between these two types of transistors. And also in case of FET, it has again several types of there. There is a junction field effect transistor is there, and MOSFET, metal oxide semiconductor field effect transistor is there. And the simple operations of a transistor, which is shown in this PPT. It's a practical connection, practical method of explanation, which is given in this slide. So here the one bulb is connected to the positive terminal of the battery, and another terminal of the bulb is connected to the transistor. And transistor, which has three pins, that is a base, collector, and emitter. Here the base terminal is left freely, and another one terminal which is given to the negative terminal. So if you connect the transistor like this, the light will not be glow. So light will be in off condition, because in a transistor there won't be, if you giving some voltage, if you giving the current in the base terminal only, there will be a current flow occurring to the emitter to the collector. So automatically after that only the light will glow. But here in this case, the base terminal is left out freely, so there won't be any current given in the base terminal. So it is not triggering any current to the collector to emitter. So obviously there won't be any current flow at the load. So it is still in off condition. So here in this base, emitter, and collector, the base is a very very important one, where we are giving based on the base current only, the current conduction will be takes place in the transistor. And in the case of here, the base terminal, here we have connected with one more battery. So automatically this creates some current flow in the transistor. So the bulb at the end, it will be on. So typically we need to apply at least 0.6 to 0.7 to the base pin, for transistor to turn on, because I already told that silicon and germanium are the popular semiconductors which we are using in the many semiconductor devices. So obviously that silicon, if you're using the silicon, that threshold value of the silicon is zero point 0.7 voltage. So the input voltage is greater than of this zero point 0.7 voltage, means there will be current conduction will take place. If it is less than of 0.7 means there won't be current conduction. So that is only here it is mentioned. So we need to apply 0.6 to 7 to the base pin for transistor to turn on. So if it is turn on, automatically there is a current flow, and the load here is a bulb, so automatically it will be glow, it will become on. And here the transistor, I told you know there is a some we can check the transistor voltage, that's a bias voltage by means of us giving the power supply to this thing. So this is a practical connection where we can give in our laboratory and we can check out the operation of the transistor. And this is the same thing. And here the transistor, in this case, in the first there is four diagrams are there. First image you can see, for the base terminal the zero point 0.5 voltage is given. So zero point 0.5 voltage is nothing but it is below zero point 0.7. It is a base level base voltage is zero point 0.5, and actually the threshold value of the transistor is zero point 0.7. So it is less than of zero point 0.7. So there won't be any current conduction across the transistor. So the LED, the red color LED will be off condition. And coming to the next image, the base voltage is increased to zero point 0.5 to zero point 0.6. So the LED will gets on, will glow in a dim manner, because the base voltage is very small. So it is a zero point 0.6 voltage only. And again, if you increase the zero point 0.6 voltage to zero point 0.7 and zero point 0.8 voltage, automatically the LED light, the red LED light at the output end will become brighter and full brighter. So what is the conclusion of this thing is, the scenario is, if you increase the base voltage step by step, automatically that will be reflected at the load side. So the load side, we here in this case we are connecting the LED, so the LED become brighter. And these are all the previous thing are we discussed about the transistor as a switch. Here the transistor, how the transistor will be act as an amplifier, that we will see. Here the mic is given to the base, and another one is connected to the collector. So and one more end will be connected to the speaker. So if the input is given, if the mic uh, if you speak in front of the mic, what happens? The mic is nothing but a one transducer that will convert your speech signal to electrical signal. Electrical signal will trigger to the base point, so automatically that will and the current conduction will be takes place. That automatically the speaker will be gets on, and we can witness the sound signal. Okay, so this is the basic operation of the transistor as an amplifier. So thanks for watching my video. In the next session of our analog electronic circuits, we will discuss the another topic. Thank you.